Oh, thank you.
Cheers.
Thank you very much.
Thanks, man.
And yeah, we get hooked till it's cool.
Yeah,
Thank you very much.
Yeah, Will and Brad and Nick and I are going to launch the Offensive AICon in October, so.
Yeah, well, we'll turn our staff on site into a working weekend. He's like, you get to work.
Yeah.
Yeah, that should be cool, man. I'm looking forward to it.
Yeah.
It's October, right?
Yeah, early October in San Diego, so
Yeah.
it's going to be good. Oh yeah, how many Dreadnought folks are down?
Mic check.
So there's actually just my...
Check.
I'm based
Check.
in Toronto.
A little more.
Greg, who's our like product guy, he was here yesterday, but he lives in the local area and he just like hangs out in the lobby.
Yeah.
So yeah, I'm with Yaga. Well, he's actually upstairs.
Yeah.
So,
You're Canadian? Or
This is the first time I've been to ShmooCon, both of us.
Yeah.
First time at ShmooCon. Well, I submitted last year.
Yeah.
I didn't accept it last
One
year.
of my best mates, he moved from
this will be our first.
London to Canada. 'Cause I'm Canadian. I used to live there, and I'm down in San Diego. But he just got the citizenship too.
Keep an eye on people, right? I mean, the whole.
I'm from Calgary.
If there's any problems.
But I was born in I was born in Oshawa.
Yep.
Yeah.
I'll do a couple announcements before your time, and then basically just do a quick intro. Brett Hawkins, Chris Thompson,
Awesome.
machine learning.
Awesome.
do life and
Appreciate it.
and stuff. Oshawa was kind of like one of the places we went, and I was just like,
I'm awake.
Oshawa.
I actually got to go to sleep.
I heard it's
my
called the
coffee,
Dirty
so-
Schwab,
There you go.
so I think you do.
Honestly, so we just like, we're renting right now.
This is the hardest time slot.
Oh, yeah.
Right,
Right after
We've never
the
been
late
East
night,
Coast, like
first one in the
suburb
morning.
to suburb.
Funny thing is,
to
Heidi
Yeah.
usually puts some good talks on Sunday.
Yeah.
She wants to try to.
Right, get people to,
It's
yeah.
not the nicest place in the world.
Yep.
We're all moving from Vancouver.
There's been a couple of
Right.
trains even where they're like,
I mean, I knew what we do. We have a yard.
it's Sunday
Yeah.
morning.
I think it's, some people might
Yeah,
stay
in the summer you can have it to Lake Country and
You're
stuff too,
gonna.
so
You
that's
also
nice.
get a lot of people coming in the whole time.
Yeah.
Anywhere.
Yeah,
But you get like 9 months of like 30 bucks.
yeah, it's,
Right now it's
Everyone's good though.
Yeah.
Oh, yeah, I've got a 2-year-old son now.
Yeah,
so that's-
I think you
that
just
keeps
gotta,
us
like,
very busy.
either accept it
So,
or head down to the
that's really
States
the
for
big-
like
the big
a month
thing
in the middle of
last
winter,
year.
or to Mexico or
I
something,
mean,
so.
you know as well, right?
Yeah,
Honestly, I
that's,
came here,
it's pretty busy.
Yeah,
Tables around.
Yeah, so I hung out with him.
this is, dude, this is
It
what.
would've been-
yeah, it's like, oh, I
last
could wear
night,
my
night
shorts.
before. Every now and then we get together, because he's in Columbia, I mean, I'm in Cleveland, and so like, I'll go to like a Columbus conference, you know.
Yeah,
It's these guys, so,
yeah.
yeah, I get to
So yeah, that'll be awesome.
It sounds like he's getting really
I just wanted
interesting.
to
The business process
say
right
thank you
too.
for the cool
Oh, yeah.
release and research.
Thanks, man.
Appreciate it.
Yeah, we'll see you. Are you going to that
That's
hackathon
really, really cool
at the end of the
stuff.
month?
Can you go still?
Oh, the
I'll
one in
go
San
try.
Fran?
Yeah.
Yeah,
No.
that's just
Oh,
like
okay.
from a
Will's
technical
a
perspective,
judge
you
on
can get so
Oh, is
far,
he?
like the technical
Yeah.
Oh, I didn't know
numbers,
that.
right?
So,
The process.
Yeah, he was, you know, Will's like, he was like, I'm a judge on something, and then Brian was like, the thing at the end of the month.
Put two together.
I think.
Yeah, we'll kind of alternate. Yeah, speaking. Yeah.
Yeah, the
Yep, absolutely.
organizer,
Yes.
Rob Reagan.
That's it.
Yeah.
Exactly. So, I think, yeah, but I mean, I wanted to, but it's investment only.
Yeah. Well, we'll catch you in Vegas or something anyway, so.
Yeah, absolutely.
All right, man, take
All
care.
right, cheers, guys.
Yep, thanks.
Where do you live, Chris?
I'm in San Diego right now.
Oh, nice.
Yeah.
Nice. Awesome.
I'm originally from Canada, but I
Okay.
had the chance to move down, and they're like, "Where do you want to move?" I was like, "Well, obviously San Diego." But yeah, I wasn't prepared for how expensive it was going to be.
Oh. Yeah, I was out there for a client event not too long ago. It was entertaining.
Yeah.
They had us at the like whatever the county's like emergency response thing was or something.
Yeah.
And it's like, oh, that's the morgue. That's the police headquarters, and then there's a random building that's like a beautiful like. This is so much nicer than any federal building I've ever been in. And they had like a local radio announcer come and MC the event. And so we're like, you know, it's like Frank, the radio guy, was actually introducing Frank to cybersecurity.
That's great.
I was like, man, I need that guy to like do all the like
Yeah,
intros.
just
He has
your
that
traveling
voice.
hype man.
Oh my gosh.
He has that tone.
Podcast voice.
Yeah. Oh yeah.
Smooth.
He's
jazz.
actually on radio. But that was a weird because the Attorney General of San Diego started us off talking about the threats of was like, wow, this is kind of a downer.
Like, and we'll be touring the morgue next.
I'll talk about cyber. I can explain more. Let's take a break, though. Let's take a break. Yeah, take a break. Let's just reset.
Oh, I gotta follow this guy. Come on.
That was exactly.
That's funny.
Yeah, it was like that. And something about like real estate prices, and man, the audience was like half asleep.
Yeah.
Trying to think about the first talk.
Yeah.
Someone's awake. Have you spoken at other conferences?
Yeah, a few over the years. I haven't spoke in, oh, that's a lie. I spoke at RSA, but it's just like one of the stupid sponsored sessions that everyone doesn't want to do, but somebody has to do. But yeah, I haven't spoken in a few years. I don't think anyways. I had a terrible memory. It's all merges together.
Yeah, it's true. Yeah, it's like we start thinking about the history of ShmooCon, and we're just like, wait, what year was that? Was here sometime over the last 15 years. Yeah, exactly.
Yeah.
I have that memory too. I feel like I was younger then. Yes, exactly. We all were.
Time has not been kind.
As time goes by, I just get younger and fitter and
Yeah.
work less. And
Yeah, I can relate. No.
less responsibility. Yeah.
Oh, I was gonna reset the timer, but
Yeah, once you start, you just hit the
check. Yeah, that sounds good.
Yeah, it's like 9:59. I'll kick off. Just read
good.
a couple announcements. Do the
I'm
intro.
gonna throw one of those out.
Young Andy with it.
I think I could concentrate that far.
Well, yeah, no chandeliers.
Yeah, no chandeliers too.
Yeah, the amount of times I've tried to throw stuff out at the final, I'm like, yeah, I don't throw things anymore. Underhand at the most. That was one of my first ShmooCons. Took a t-shirt and was like, yeah, let me just throw this. Being someone straight in the head. I wasn't looking.
That big.
Morning. What time did you get to sleep last night?
Stop looking at clocks after a while.
Yeah.
I actually came down here at 9.
Oh.
Because I thought your talk was at 9.
I had a moment of panic at 9:01. I was like, wait a minute. Did I get the time wrong?
I just looked at my schedule card. Okay, no, I didn't.
I was almost that guy.
No, well,
Well, I guess I was that guy.
yeah, that's fine. I can get it ready.
Cool. Are you guys good?
We're good. Get this out of my eye.
Good. Good morning, ShmooCon. Happy Sunday. Last and final day of ShmooCon. Obviously, going to be an interesting day, but we have a couple good talks today that I think will really help us send ShmooCon off in a very good note. A couple announcements for me before we get started. Please feel free to stop by the registration booth. We still do have some t-shirts available in a limited number of bags, so there is still some stuff that you can make sure that things that we don't have to take with us. So we'd much prefer you to take them. So please swing by, take a look what we have, and we also do have a number of items in the Lost and Found. So if you're missing anything, please do stop by before the conference wraps up. Anything that's left will end up at the hotel. Also, former speakers and Shmooza student participants, please check your email for a message from Heidi. There's something in there very important for you. But with no further ado, next up we have Brett Hawkins and Chris Thompson, who's going to make us a bit smarter on machine learning models. So please put your hands together. Welcome.
Thanks. Thank you, sir. All right. Good morning, everyone. Thanks for coming out. Last and final day of ShmooCon. Really honored to be part of it. So thanks for having us. Today we're going to talk about abusing MLOps platforms to compromise models and data lakes, and generally just go after different objectives on the internal network. So intros. I'm Chris Thompson. I lead the IBM X-Force Red team.
Then I'm
Brett Hawkins, one of the team leads at X-Force Red as well.
So last week we released a white paper and the open source tool for this, so encourage you to check it out. You can find it pretty easily, so feel free to scan the QR code or just go on Twitter. But you know, the white paper is really detailed, so a lot of the attacks go into a lot more detail, as well as the detection and threat hunting guidance. So definitely check that out. So today we'll be covering the toolkit that we built, kind of a background on MLOps. We'll be giving an overview of different attack scenarios, demoing the tool that we built, and giving some detection and configuration guidance around it. So, Brett, you want to introduce yourself again?
Yeah. So yeah, like I said, I'm one of the team leads at X-Force Red. I've written a number of open source tools, spoken at some different conferences there. If you're interested in any of my public security research, so that'd be white papers, presentations, tools, blog posts, I've got that URL listed there. I've got them all kind of cataloged there.
Awesome. And as mentioned, I lead X-Force Red. I started the adversary services team there, or the red team there, about 9 years ago. Since then, I've focused kind of moving into a new role, but I've spoken at a lot of conferences over the years. I'm on the Black Hat Review Board, and the co-founder of an upcoming Offensive AI Con, which if we have some time, I'll chat about at the end. So talking about the drivers for this research, we know that basically every organization out there is trying to slap AI on everything, for better or for worse. So a lot of organizations are downloading open source models, tuning them. There's larger organizations training large language models. There's a lot of small language models being trained and tuned out there. And, you know, we really, looked at, there's a big gap in offensive and defensive research around the environment used to train and tune and deploy and manage and maintain these models. There's no tooling out there to simulate attacks against those. And there's not really any detection guidance or threat hunting guidance out there. So, another piece we wanted to really cover in on is the terminology AI red teaming. It really only covers models, right? And as a red teamer, I think of the wider environment. I think about all the interconnected systems. I think about the servers that the models are running on. I think about the apps that are deployed. I think about how these models are managed and maintained. And so when I think about AI red teaming, it's really about the wider ML ecosystem as well. So we're talking about like the training environments, the tuning environments, the deployment orchestrators, the orchestration plugins, the APIs, the agents that are running, all that has associated infrastructure that's interconnected into different IAM systems and whatnot. The goals for this research are really to start the conversation. We wanted to provide an open source tool that others could contribute to and build off of. We wanted to inspire more research in attacking and therefore defending these platforms. And we wanted to really just bring attention to an area that not a lot of people are looking at as organizations are rushing into AI. Takeaways, you'll learn how to start to simulate attacks against these platforms, how to test your detections, how to leverage the toolkit that we give you to streamline those attacks. You don't have to conduct them manually, and hopefully inspire you to contribute as well. So what's new in this research? There are some white papers out there about attacking platforms, but there's really, there's zero tooling out there until, last week. There hasn't been any public talks on REST API abuse of these platforms to conduct actions like model extraction and data extraction and whatnot. And there's no, real detection rules to ensure that people are well prepared to defend and detect against these types of attacks. So, we're offensive security experts. We're not data scientists, we're not ML engineers. We certainly work with them on the IBM side, but we're bringing our perspective as how would we attack these platforms? How would we attack these AI environments? So there's not a lot of prior work in this space. Adrian Wood and Mary did some really great talks basically around supply chain attacks. So they put out, infected or backdoored models onto Hugging Face to show, how data scientists who are constantly downloading and evaluating models, are putting the organization at risk. There's Nitesh did some interesting kind of academic work. Same with Florian and the rest of the folks, listed out there. So our research really builds and differs upon these works because we're focused on the wider ecosystem and really taking into consideration the red teamers' perspective on the wider attack paths. So for some background, what is MLOps? Well, it's the practice of deploying and maintaining models in a secure, efficient, and reliable way. So how do you evaluate and test and train and tune models? How do you deploy them, manage, monitor, maintain them? The goal is really to have a consistent automated process to deploy ML throughout an enterprise or a production environment. There's 5 kind of phases involved in the MLOps lifecycle. You have design, where you're collecting your source data sets, you're sanitizing that data, you're tagging it, you're getting ready to train a model or tune a model with it. You're developing and building that model. You're leveraging those big GPU banks to actually tune and train models. You're testing the models, you're deploying it, and then you're managing it once it goes into production. So there's a lot of popular open source ML platforms. We initially didn't focus on these because we wanted to focus on the commercial ones. We're expanding our research this year into a lot of ones that you see on this slide. But we wanted to focus on the more popular commercial MLOps platforms to start, because these are the ones that most organizations are rolling out with initially. So you think about Azure ML, you think about SageMaker, Google Cloud Vertex AI. That's been the real research focus, but being in DC, there's lots of other companies like Palantir and whatnot that have AI platforms that should definitely be third-party tested. And so hopefully in the future, either we'll expand our research in this area, or if anyone in the room wants to collaborate, don't hesitate to reach out. We're really just trying to get the ball rolling here. It's early days, just like when any new cloud platform gets rolled out, somebody's got to dip their toe in the water and get it started. So we think about a typical Gen AI solution. This is kind of what we're talking about when we think about AI red teaming. On kind of bullet 2 there, where you have the models, a lot of the focus in the industry right now is how do you do like direct and indirect prompt injection? How do you do model and weight extraction? How do you do adversarial evasion and membership inference about that model when it's running in production? But there's all the wider ecosystem that we want to really focus on is all the integration into these wider ecosystems and IAM and whatnot. So, you have the ML pipeline, the ops pipeline for training and tuning and RAG. You've got the platforms that the models actually run on, like Big ML, like watsonx AI, like Azure ML and SageMaker and whatnot. Then you have the models themselves running on those platforms, and then you have the applications that are actually interacting and using those models, such as a Gen AI application. So when we think about threat actor motivation, we think that there's a much wider expanded attack surface as a result of basically every single organization rushing into AI. These platforms have direct access or sit adjacent to enterprise data lakes and crown jewel data, and they're integrated with core backend systems. They're integrated with virtual infrastructure and container infrastructure. They're integrated with IAM. So they represent like a really juicy target as red teamers. So if you are able to compromise these systems, you'd be able to quickly land, gain access, expand access, perform lateral movement within the target organization. And key that, I talked to a lot of IR teams at different clients, and nobody has threat hunting playbooks developed for these environments yet. Nobody has detections rolled out. Most of these commercial platforms, detections not even enabled, or detections and audit logging is not even enabled by default. You have to manually go in and do it, let alone ship those logs to a SIM and start to build up custom rules for it. So, that's pretty scary when you think about how new this technology is and how many people are rushing to roll it out. And the IR teams don't have the training, they don't have the knowledge and familiarity with these systems, so they aren't prepared to just spot, a backdoored model. They aren't prepared to spot somebody attacking this infrastructure from either, within the MLOps pipeline or targeting of the MLOps pipeline. So I really, as a red teamer, like to think about the motivation of different threat actors targeting these platforms, and they're going to have a variety of goals. So starting kind of at the bottom, the most basic of threat actors are going to reuse public tooling and research to attempt to, maybe perform some sort of resource exhaustion attack or DOS, where basically they're just forcing organizations to spend a lot of money and resources because they're sending a ton of queries, using up a lot of tokens. More sophisticated threat actors, they might seek to perform wider scale supply chain attacks or seed backdoor models. So much like the research that Adrian did, throwing up some backdoor models on Hugging Face, we see in the last couple of years that threat actors are really starting to target supply chain attacks. So whether that's kind of targeting, malicious Python, builds out there, or now having the ability to backdoor models, we see, a lot of targeted tier kind of threat actors will likely be expanding their attacks to this domain in order to gain initial access and, initial access brokers to resell the access that they gain. More advanced threat actors, they might focus the research on model extensions like safe tensors designed to prevent common malicious model attacks, or they might seek to, chain vulnerabilities so they can do containerization breakouts and whatnot. We recently had a really large bank ask us to target their AI-based fraud analytics platform. So not only to steal the ML models that their quantitative trading algorithms use, but also in their AI fraud analytics platform. So how they're spotting wash trading and different malicious stock trades. One of our red team goals was to actually compromise the platform, modify the model, modify the rule set so that malicious trades can't be detected, for example. So that's the same type of, advanced threat actors when they're doing financial fraud and they're trying to go after these types of environments, similar types of goals. And then top tier states and nation states, state-sponsored threat actors. We know that China's invested a ton of money in AI, both to develop their own models as well as to go after, stealing models that other nations have developed, and it just makes good business sense, right? Why would you spend all that GPU time and money when you can just, steal another country's model, right? And that's not just for commercial model use. There's a huge field around military use of AI for satellite imaging and SAR image recognition around, like, how do I spot troop buildup on a country's borders, for example? How do I differentiate between a school bus and a tank? And if you can backdoor those different models and you can make the model useless, you can, disrupt the other adversary's, advantage using these models for defensive purposes. So there's several kind of well-known attacks against the MLOps lifecycle, but again, there hasn't been, ways to actually conduct these attacks and how to detect them, and that's what we're going to be covering today. We're covering a kind of a smaller iteration of these attacks, but again, just check out the white paper and there's a lot more details. So aligned to the previous slide, each stage of the life cycle prevents opportunities for abuse. In an ML training and tuning environment, an attacker would, have access to the raw source data or the training data set and can modify it. In public data sets, attackers might publish malicious code, which may be suggested by like coding assistants like cursor.ai or some generative AI coding assistant. And we saw a talk just yesterday where one of the researchers realized that the coding assistant was just using like the highest upvoted code repo to suggest code, and not a lot of upvotes were registered, so he just created 100 bots, upvoted his malicious repo, and then suddenly the generative AI coding assistant was suggesting malicious code repos, right? So they really want to, the outcome is to influence the training data that eventually gets deployed into a production model. So some example goals might be to compromise an AI-based fraud analytics platform to allow for restricted actions or modify fraud algos or ignore alert thresholds. If you can poison the trained model or the model training data related to image recognition, predictive AI, or early warning systems, again, you can have an advantage because maybe a nation state can't see, a warship moving through the ocean and they'll just, misidentify it as a cargo ship, for example. You also might be motivated to have a model ignore specific IOCs for security helper kind of AI tools that are out there. So, Microsoft Security Copilot, which is all about reducing the need for human IR people by using algorithms and ML to do that. Well, if an attacker could target an EDR platform model training set and specifically poison that data to avoid flagging certain actions or domains as malicious, then you'd have a huge advantage in like a future campaign, right? Thinking about like data extraction, really that's where you're targeting the data set itself before, like after it's been kind of trained, after it's been trained. So the private data set might have sensitive information such as like financial or healthcare information in that data set that would be of huge interest to, say, a ransomware group that wants to steal that data and ransomware it. Or if it's a coding assistant, for example, a lot of big organizations are training their own or tuning their own models on their internal code bases, right? So think of a big computer manufacturer, modem manufacturer who has all this really sensitive data on their internal intellectual property and their source code. They're training these repos on that really highly sensitive code base in order to assist their developers. But if an attacker was able to extract that model, it could contain really sensitive information about their source code, for example. Model extraction, an attacker could use a stolen model to, again, extract training data and the training weights that were used. If you stole a model that was used for financial trading, maybe you could use that to your own advantage for predicting commodity futures, for example, or you could steal, again, that trading algorithm or whatnot and sell it. We did another red team op for a bank that had us target their ML infrastructure, and they placed the value of a single model at $4 billion, right? So this is a competitive advantage to these banks. They allow for sub-millisecond trading, for example. You might also want to steal these models to better understand the limitations of models used by EDRs or SIMs or defensive systems and plan potential evasive or mitigative options. So again, going back to nation states, for example, if you understand the limitations of those models, you can then either plan compensating actions or whatnot. And really, you have the ability for an attacker to steal a trained model either before or after deployment. So whether it's in your model registry sitting there or when it's actually been deployed to a production platform, for example. And then kind of as a red teamer, the holy grail
QR code as well. This allows, kind of Chris talked about the REST API abuse of these platforms, using things like stolen API keys or access tokens to conduct those actions. For the initial release, we've got 3 supported platforms listed there, 6 different modules. This is just the start, so this summer we're planning on adding some more platforms, some more different types of attacks, so definitely keep an eye out there. But you're going to see this tool in use. We've got a few demos put together for you all. So now we're going to get into actually kind of attacking these platforms. So kind of Chris talked about a background of how these platforms fit into the MLOps lifecycle. Now let's talk about actually doing these different types of attacks against them. Starting off with Azure ML. Just a kind of a one-page slide, 10,000-foot view of what Azure ML is. This diagram is from the folks at Trend Micro. There was a really, really good diagram they had posted. Your kind of centralized hub where you work from within Azure ML is a workspace. And then from there, you're going to have access to different things like your data sets, your models, any type of ML pipeline or workflow. That's going to really be kind of where you're working from, is that workspace. And authentication, there's a bunch of different options for authenticating to Azure ML. You could authenticate to the actual web portal there, like with your Enter ID authentication. You could do service principal authentication. You could use credentials to authenticate with the Azure CLI, managed identities, as well as one of the things that we really abused was the access token piece, so authenticating to the REST API with an access token. There's been a lot of really great research out there on different ways to steal like Azure access tokens, whether that be like social engineering or stealing from user workstations. There's a lot of different options, and again, a lot of really great research on how do you get that access token. From a logging perspective, logging is not enabled by default, so you need to enable diagnostic logging within Azure ML itself, and then make sure you check that box for the audit logs. That way you can get those logs sent to something like a log analytic workspace in Azure, and then build detections. And that's part of the things, something that we did as part of this research that's included in the white paper. In the white paper, we have detailed commands on how you do these attacks with like kind of the raw REST API, but this is just kind of like a visual representation of the different REST APIs that you would need to utilize in order to do something like reconnaissance or model extraction, training data set extraction, etc. So the first demo kind of scenario we have put together for you, we have 3 demos. I think we're going to do 2 demos just in the interest of time. But this one, so let's say you do an Azure device code phishing attack against a data scientist. I mean, it's a very common type of phishing attack that we do on engagements and you see out in the wild. You've got this access token as this data scientist. Now you have access with that access token to Azure ML. So what we're going to show in the demo is we've got this access token from the device code phishing attack. And what I'm going to show is using MLOKit to actually perform reconnaissance in Azure ML and then actually steal a model. So first here, we're just kind of listing the stolen access token just to show you the access token that we have. So again, there's a bunch of different ways you can steal an access token. This attack scenario, we've stolen it via a device code phishing attack. So we've got this token. The next thing we're going to want to do is validate that that token is valid and that we have access. So using MLOKit with the check module. So you basically specify your platform, your credential. So again, we're passing in that access token. You're going to see we have access here with this access token, and it's going to list the different Azure subscriptions that we have access to. So a Azure ML workspace is going to be tied to a Azure subscription. We're going to copy out the subscription ID here. That's going to be a very useful piece of information that we need for these subsequent commands. And so now that we've validated access, we want to list what Azure ML workspaces or projects that we have access to. So we're going to paste in that subscription ID and see what workspaces we have access to for that subscription. So we'll go ahead and run this here with the list projects module in MLOKit. And there's going to be one workspace in this example. We'll kind of zoom out here. So this test workspace. So we have access to this workspace via the subscription with this token, again, that we stole from a data scientist. And we're going to copy a few pieces of information out. So a workspace is going to belong to a resource group and a region, and so you'll need to copy that information out, because what we're going to do is we're going to list any models within the model registry for that workspace that is in that region, that resource group. So now we've got the projects or workspaces we have access to. We're going to start listing out what models that we have access to. So we pasted in the information from that previous command. I'm going to go ahead and run the list models command here. And again, these are going to be any models that are within the Azure ML model registry. Think of a model registry as basically like a way to track like the different models that you've developed. And so we're going to go ahead and list the models here. And we have access to a few. It's going to list out, what type of model is it. In this case, these are ML flow models. And the most important piece of information here is going to be the model ID. So to download or steal or exfiltrate one of these models, you need to download it by the model ID. So we're going to go ahead and we're going to copy one of these model IDs out. And we're going to run the download model command. So this is going to exfiltrate the model. And so what's that's going to do? It's going to download like the serialized model file. That's the juice right there. That's the real sensitive thing. And then also included are any type of like requirements or environment, like things for like actually kind of using that model itself if you want to, like a Python requirements file, or if you're using Conda, like an environment file for Conda. So you can see here the model registry, or like the backing, is going to be like within Azure. So think like Azure Storage, like an Azure Storage blob, storage account. And so you can see here we put that model ID in there, and it's going through, it's grabbing all of the basically the storage account URLs that we need to actually download all these files. It'll create a directory for you and then download all those files. So again, if I'm going to list the directory here, you're going to see we're going to have like the model pickle file. That's the serialized model file itself, as well as any like what dependencies that we would need for that model. So again, just to recap, this kind of shows doing a Azure device code phishing attack against a data scientist, and then utilizing that access token to then steal a model from Azure ML. Now, we've got detection guidance in the white paper, and we've got some KQL queries and stuff for this attack, but for actually like grabbing a model, it's going to be logged there in the AML models event schema, and I've got the operation list there. Again, in the white paper, we've got like detailed detection rules and such. So for BigML, this is another one that we've been looking at, another commercial platform. It's used by a lot of companies. If you look at their homepage, you have organizations. So a BigML instance, you can have one-to-many organizations. Each organization can have one-to-many projects. And within a project, you have a data source. So that's going to be your raw data. You transform that into like structured data, so a data set, and then you can use that data set to train a model. It could be like a classification model or something like a regression model. And a user can belong to one-to-many organizations. To authenticate, you can authenticate with the web interface. It supports MFA. The REST API, you use an API key to authenticate to that. That's something that we abuse within MLOkit. And also they have like a command line tool called BigMLer that you could use. It's like a Python-based tool that you can do different things with the platform. In terms of logging, so you need a private deployment for the logging ability. And so we didn't get to look at the logging for this platform because in like the cloud-based BigML, there isn't any type of logging available. So we didn't actually get to look at like what is logged when you do different attacks within BigML. For the different REST API abuse cases, in the white paper we've got detailed curl commands, how you do all this, but this just kind of lists out at a high level. You have an API key for BigML, what APIs you would utilize. Now I'm gonna skip the BigML demo just in the interest of time because I think the Vertex AI one is a little more interesting that I'll show next. But just an attack scenario, you could, for example, like find an API key on some type of public source code repo and then use that to access BigML. And then with MLOkit, you could do things like steal private training data sets that could have sensitive data or models, whatever's in BigML. So we'll make sure we'll release all the demos this week, so you'll have this one as well. But just to kind of show an example attack scenario with Big ML. So the last platform we're going to cover is Google Cloud's Vertex AI. So this is a very common one that we see in environments. So basically, and this is again a very 10,000-foot view of Vertex AI. You have projects just like in Big ML or Azure ML, and you can have one-to-many projects. Within each of those projects, you can have like an ML pipeline, which includes things like your data sets or any other input files that you want to feed into the pipeline to actually have a model come out on the other end. Again, this is just a very 10,000-foot view of what Vertex AI is. We've got a bunch of different references in the white paper if you want more details about Vertex AI. To authenticate, you can authenticate to the web console. You could authenticate with the Google Cloud CLI, as well as there's these things called application default credentials that some client libraries use. That's another authentication mechanism. Again, different ways for getting these type of credentials. It could be social engineering. It could be internal file shares, internal wikis. A bunch of different ways to kind of get credentials to access these type of platforms. Now for logging, again, just like Azure ML, logging is not enabled by default. So there's a couple different things. You want to enable the Vertex AI data access audit logs, as well as the Google Cloud storage logs, because that's kind of like the backing storage for things like models and data sets, is that Google Cloud storage. And again, just to show a high level of the different REST APIs that you would need to utilize to do these attacks. With MLOkit, we've abstracted all of this to make it easier to be able to simulate these attacks. But in the white paper, we've got like the raw kind of curl commands for what commands you need to do in order. It can get a little tricky, so I'm glad we have the toolkit because it makes it way easier to do these. So the demo we're going to show, so here's another attack scenario. So an attacker, right, they fish in an organization, they've got a command and control beacon running. From there, they use something like Active Directory to escalate their privileges in the environment, and then laterally move to a ML Engineer workstation. In this case, this ML Engineer, they use the Google Cloud CLI to access like Vertex AI. And so what we've done here is we've stolen an access token as that user to be able to use against Vertex AI. And so what the demo is going to show is using this access token to actually steal a model from the Vertex AI model registry. So we've got this access token here. Again, we've got this Cobalt Strike beacon. We've already grabbed the access token from the user's workstation. There's an access token SQLite database that gets logged in. So we've stolen this access token. And the next thing we're going to do is we're going to take this access token and see what projects in Vertex AI that we have access to. Then after we list out the different projects that we have access to, we're going to list out the models that are available to us, and then ultimately actually download or exfiltrate that model. So we're going to go ahead and run the list projects command here. So again, it's going to validate your credentials, that access token, and it's going to list out the projects as well. So you can see this running here. There's going to be a few different projects that we have access to. We're just going to copy one of these out. I believe it's the Coral Marker project. You want to copy out the project ID, not the project name, when you're doing things like model reconnaissance and such. So we copy out that project, the project ID. Now we're going to list all of the models in the model registry that are associated with that project. And so we're going to run the list models command here. And this is going to give us a few different models that we have access to. Again, this is in the Vertex AI model registry. And in the model registry, like when you have something listed, that ties to what are called kind of like, they call them like experiment runs, which is basically you run a bunch of experiments, produce a bunch of models, and then you can choose which one was the best one and put that in the model registry. So this is specifically grabbing any that are in the model registry. And so it's going to give you some different information, but just like with Azure ML, you want to grab the model ID to actually steal that model. So this model here, we're going to copy out the model ID. And now to actually download the model, I'm going to run it from my local attacker box versus doing it via the command and control beacon. That way, the files aren't directly getting downloaded to the victim machine. So I'm utilizing something like a SOX proxy through a command and control implant to proxy that traffic through, and then I steal that model directly to my attacker box. This module here with Vertex AI was probably the most difficult one because there's a lot going on here. In order to download or exfiltrate, steal a model, you have to first export that model from the model registry, and you can only export it to a Google Cloud storage. And so it figures out what Google Cloud storage you have access to. It'll export the model and all of its associated files to that Google Cloud storage, and then it downloads them all, maintains the same directory structure as well. So you can see here, kind of the back end, it's downloading all that via the Google Storage API, REST API. And then if we actually kind of look on our system, it's going to maintain that directory structure. Again, it's going to have the serialized model file and any type of like dependencies, things like that. So this one was a little more complex to actually get working programmatically, but just know that it is possible to do this. And just to kind of recap again, this attack scenario, attacker gets into an organization with phishing, they escalate their privileges, they laterally move to an ML engineer workstation, steal that user's Google Cloud access token, and then use that to access Vertex AI and steal a model. And in the white paper, there's some different methods that you'll want to kind of filter for how this attack activity is done. So a couple different methods for actually exporting the model. And another thing that you can do is kind of build like a list of different serialized model formats and see when those are touched within Google Cloud Storage.
So some configuration guidance for Azure ML. You want to make sure you're managing your ML asset inventory. Just like any other cloud platform or emerging technology, you want to incorporate these scenarios into your threat modeling exercises. If your company's invested a lot of time and resources into moving to AI, and they've integrated sensitive data sets or sensitive actions, maybe it's a banking application that can perform wire transfers or set up new accounts, there's a whole new swath of attacks that you need to start threat modeling for, both against the ML model, but more, in my opinion, importantly, against the MLOps infrastructure and surrounding types of areas, because you might find some interesting prompt injection in a model that allows for you to perform sensitive actions, but guardrails are getting better. Maybe that won't be possible in the actual GenAI app. So an attacker is just going to go after that back-end infrastructure instead, just like we do all the time during red teaming. So make sure you're threat modeling for those scenarios. Really just follow data and ML workflow security best practices. Enable audit logging because it's not enabled. Big ML, enable MFA, it's not enabled by default. Perform credential rotation often. And ensure that you're applying granular access controls. You're not giving everyone in the organization admin within Big ML or every developer admin. Vertex AI, again, apply that principle of least privilege, just like you would with any other sensitive asset, any DevOps environment that can be abused for lateral movement and priv-esc. Make sure you're using IAM to manage roles and groups and getting very granular there. Google actually has a thing called Security Command Center that they recommend to be implemented for Vertex AI, so actually put that in place and enable those audit logs because none are enabled by default. Detection guidance, the white paper goes into tons of threat hunting queries and KQL queries and stuff, so really these are just a summary of different log schemas and the operations associated with the attacks for Azure ML. For Big ML, because you needed a private deployment to enable logging, we never actually went about doing this. And Vertex AI, here's some of the method names that are going to be required for implementing detections. So the MLO kit, again, it's open source, it's public. We would love to see contributions for different ML platforms. There's YAR rules for detecting MLO kit. There's snort rules for some hard-coded user strings we put in there, just so there's a potential for detecting this tool used maliciously. There's suggested Sentinel rules. and there's suggested Google Cloud Alert policies for use. So in conclusion, securing this MLO ops is going to be critical. You really want to start simulating attacks against these platforms and building out those detections, understanding how to threat hunt in these environments, understanding how to ship the logs and telemetry from these environments into your SIM, and making sure your IR and threat hunters actually know what they're looking at. This is really new technology. A lot of people are pretty overwhelmed by just how much they have to learn right now. And as a result, attackers are going to start going after these platforms because of just how juicy of a target they are, how much credentials and access that are within them. You really want to start to really focus on how do you get into an MLOps environment, whether that's targeting a developer workstation, whether that's backdooring a model, putting something up on Hugging Face. Hugging Face, for example, it only uses Clam antivirus, which is limited to 4 gigs for scanning. Like there's no live model deserialization checks or anything like that. And data scientists are downloading dozens and dozens of models to evaluate their performance in these solutions, and they're executing them on their workstations, right? So it's just a matter of time before we see a lot more of these supply chain attacks through just backdoored models, backdoored, Python repos and whatnot. So you really want to make sure, as defenders, you know how to spot C2 beaconing out of your training and tuning environments. You really want to spot how somebody's laterally moving between these platforms, performing PrivEsk, all that sort of thing. So leverage MLO kit to do that. Any questions? Yes, sir. You get the Yeah, honestly, it wouldn't create a lot of noise. Auditing's not enabled by default, for example. If you're going over a SOX proxy, that's just going to be downloaded in usual traffic to a developer workstation. So it's kind of about context. If you are going to steal that model, steal it from an area that you expect the model to be downloaded, so beacon through that developer workstation, for example. Gentleman to the left.
Yes, hi. Are the slides going to be available after?
They will, yep.
Yeah, we'll post them this week on social media. We'll make sure we post that, and we're going to post the demos as well.
Any other questions? One more time.
Do you have any suggestions for model authors on how they can assess
Can anyone else repeat that for me?
Do you have any suggestions for model authors
Ah.
to secure it?
Repeat the question, please.
Do you have any suggestions for model authors to secure the model? Beyond traditional AI red teaming of the safety and security of the model, really looking at how, as a team, you're monitoring and managing access to your model registries and your training and tuning environment, and ensuring that you're working with security teams and security engineering teams to integrate detections for those different tools out there. Especially if you're self-hosting a lot of these data science tools. They've been written by, PhD students and guys in, just on courses. These are not robust commercial coded tools for data scientists. These are like tools that allow like Python deserialization really easily, right? So there's a huge potential attack surface in these data science tools as well as in these platforms, and you want to make sure you're having those conversations. Next question. Perfect. Well, just last but not least, working with Dreadnought and Kristen Del Rosso and myself, we're going to be launching the first Offensive AI conference in October. So just quick shout out to that. This is really about offensively using AI, so both in agentic workflows and in ML workflows. The team, like Chompy and Ruben on our team, for example, they've been really successful leveraging AI in their exploit development workflows. We're leveraging it in our red teaming workflows, and we really just want to start having a conversation in the industry and try to steer responsible use of AI offensively. Go ahead. Early October in San Diego. We're still negotiating with a couple different venues on the actual dates and location, but early October this year, San Diego.
we're good. Thanks everybody, and thanks ShmooCon for having us.
Thanks. Oh man, I was nervous. It's just out of practice. Hey.
Thanks a lot, Frank.
Maybe I'll see you in San Diego.
Yeah, that's right. That's right. Beautiful city.
It's always a fun city to visit.
Yeah, I've only been there once, and it was awesome.
Yes. Hey, good to see you. Good to see you. Oh, nice. Oh, yeah, yeah. Yes.
So, yeah.
Uh-huh.
So, yeah. But I'll come
Yeah,
yeah,
we're at
I'm gonna come out here.
JP Morgan Chase now, so it's fun. Yeah, definitely. Cool. Yep.
It is, but there's been a small group.
Yes. Cool.
8 years been going. Hey guys, stop talking about adversarial behavior. Let's start talking about the ecosystem. Right. And it's just like, you know, hammering people in the head. And especially when you're talking about adversarial behavior.
Are you up next? Yeah. Oh, awesome.
Yeah, it's like that Thompson.
Hi, I'm Frank. Good to meet you, Frank. I'll be introducing you. So get over whatever you
It's
need
very
set
simple.
up.
Just tell them the smartest, the brightest, and the most modest. The most modest. That's what's
How
important.
do you say your name? Casimir?
Krassimir.
Krassimir. Yes. How do you say your last name?
Tzvetanov.
Oh boy.
Tzvetanov. Try this. Tzvetanov. Tzvetanov.
Tzvetanov.
Tzvetanov.
I'll do Casimir. How's that?
Yeah.
Krassimir. Yes. I can't do that roll. It's got a problem. Krassimir.
Yeah, good to see you. Yeah, you too.
How do I connect to the display? I don't see.
Anything really.
Oh, do you have a?
Develop like a base framework, so a lot of like our internal attack tools
also
start
not
like small
recorded.
like this, and now they're like 60 modules big and stuff. So that's really what we're just trying to do. So.
If you have an adapter,
Yeah, appreciate it.
That's a good point. Thank you.
for you too comfortable there.
No. I actually don't like the seat. Correct. Thank you, sir.
Thank you.
Do you have a clicker?
Yes, it is live. It's hot.
Do you have a clicker by chance?
We can ask.
Can you go?
Sorry, guys. It's pretty new. It's really about like I think I gotta get off stage here in a minute. Here, what time are we? It's really about the